All right. We're looking at other geometric figures. We talked extensively about triangles. We talked about circles. But we're going to go and talk about other figures as well as revisit the triangle and the circle. It says when part of a plane is bounded and closed by straight line segment, it's called a polygon. The root of that word is poly. Poly means many. So polygons, a triangle is a polygon. It has 3 sides, tri. A quadrilateral has 4 sides. It's a polygon. A pentagon has 5 sides, and a hexagon has 6 sides, and it keeps on going. So the 2 polygons that we look at most is a triangle and a quadrilateral, the one with 3 sides and 4 sides. So we're going to look at triangles and quadrilaterals as well as the circle. One thing to remember is that the sum of the interior angles of a triangle, it is 180 degrees. The sum of the angles of a quadrilateral, therefore, it's 360 degrees. Those are 2 very important things that you need to remember. Okay? In chapter 6, we talked about the radius and the diameter of a circle. We had formulas for finding the area and circumference. Now we extend that. 2 circles with the same center are called concentric. So this one has the same center. It has different radii. And if we have a circle, it says a line segment having its end points on a circle. It's called a chord. Okay? This is a chord and this is a chord. This chord here is also the diameter because it's going through the center. But a chord does not have to go through the center of a circle. A tangent line is a line that touches the circle at one point and it does not pass through, so that's a tangent line. A secant line, however, passes through 2 points of a circle, so that's a secant line. The central angle, a central angle of a circle is an angle with its vertex at the center of the circle. An arc of a circle consists of that part of the circle between and containing the 2 points on the circle. So from here, from A to B, is called an arc. An arc is measured by its central angle. It says, and this is very important, if an arc has a central angle of 50 degrees, then the measure of the arc is also 50 degrees. So the measure of a central angle, which a central angle, its vertex is at the center of the circle. The measure of that central angle is 50 degrees. Also, the measure of that arc as well is 50 degrees. We have what's called an inscribed. An angle is inscribed in an arc if the sides of the angle contain endpoints of the arc and the vertex. So we have the vertex here. We have points there on the circle. Now notice these lines go on out, but this is called an inscribed angle. And this is very important. An inscribed angle has a measure that is 1/2 the measure of the arc. So if you know the measure of this arc, take half of it and you'll have that angle. Or if you know the measure of that angle, double it and you will have the measure of that arc. So we're going to look at a few questions. In the next few problems, they want us to find angle A. So we're looking at figure 13.30 part B. So we're looking at this one right now. And they want us to find angle A. Well, this is a triangle, and a triangle has 180 degrees. And we have a right angle, and we have a 48-degree angle. So that's going to make angle A, in this example, part B, is going to make it 42 degrees. That's angle A for that particular picture there. Then we go to part of figure D. They want to find angle A. Well, we have an angle of 110 degrees. Now, one thing we need to mention is that if these sides are equal, and they are, then the corresponding angles are equal. So angle A and angle B are the same. So angle A is going to be 180 degrees minus, because we have 180 degrees in a circle, it's going to be minus 110 degrees. And then what's left, we're going to take half of it. Because remember, 180 degrees in a triangle, we know one of them is 110. We know angle A and angle B are the same. So we take that difference and we divide it by 2, and that's going to give us angle A in this picture, and that is 35 degrees. Okay. Next we're going to look at number 8. Here we're looking at this figure, part D. Looking at that one. And what they want us to find here, again, is angle A. Now, here we know that this side is 6 and this side is 6. So this angle, and this side is 8 and that side is 8. So this angle here, 78 degrees. Is going to be corresponding to this angle here, which is 78 degrees. And what that means is that angle C and angle A are going to be equivalent because they have the same sides. So remember, now they're 360 degrees in a quadrilateral. So we subtract 78 degrees, we subtract the other 78 degrees, and we divide by 2 because what's left, we have to divide it between angle A and angle B. So this is 102 degrees. All right, let's look at number 14. Now we're dealing with circles. It says find AB. They want to find this arc. Excuse me, I'm looking at the wrong one. We're looking at 13.33B, so we're looking at this one. They want us to find this arc here if we know that this angle is 118 degrees. Well, if you remember, we said that, and this is a central angle, by the way. Vertex is the origin. The central angle is equivalent to the arc. So this arc, AB, is the same measure as the central angle, 118 degrees. Next, we're going to look at figure D. This one. It says find ABC if you know that AC is 180 degrees. Well, we said this was the central angle. This one is an inscribed angle. And we know that with an inscribed angle is half of its arc. So we have the arc being 180 divided by 2. So that angle ABC is 90 degrees. All right, next we're looking at this example. This picture here. They want us to find a tangent line. Remember that a tangent line crosses, or not, it doesn't cross the graph, but it touches the graph at only one point. So this this line here, AG, can be considered a tangent. You can really extend that to AF, but here they say AG is a tangent line. All right. Number 20 says they want us to get an inscribed angle. Okay. An inscribed angle. And remember, we're touching the vertex here. So we have GCB. That's an inscribed angle. One more. Number 27. They said that the angle BOG is 60 degrees. They want us to determine the angle BCG. BCG. Let's mark that in another color. BCG. Okay. BCG is an inscribed angle. Okay. The angle BOC is a central angle. Okay. And this arc is going to be 60 degrees. Remember, a central angle is the same measure as the arc. But an inscribed angle is what? Half of that arc. So this angle BCG is 30 degrees.